But cross-sectional versus longitudinal studies versus sequential designs. Cross-sectional studies are the typical kind of rounding up the college students and comparing them with a group of older adults. At the very least, this confounds cohort effects and age effects because the older and younger people are both at different points in the life cycle and also from different cohorts. So, and that can cut either way. In fact, it can cause you to overestimate age effects if later born cohorts tend to do better on things. It can cause you to underestimate them if the earlier born cohort tends to do better on things. I've already talked some about the longitudinal studies are a more intuitively obvious way to study developmental aging. If you want to know about aging, you round up a group of people and you watch them get old. It takes a while. So they have their own kind of issues. The simplest of which is just that anytime you are asking people to come back, you lose some. And you ask them to come back again, you lose some more. And so you don't have the same people, years down the line that you actually started with. This would be fine if you lost people randomly, but you don't. And it's very systematic ways that attrition plays out. You lose people who are sicker. You lose people who are more likely to die early. You lose people who are less educated. You lose men more than women. You lose minority groups more than whites, typically. So you can end up with a very different sample by attrition. And you want to, if nothing else, you want to look and just see. They will always report, here's how many people we started with. This will be in the methods section, by the way. It's never in the abstract. The abstract says, this is a sample of 2,500 people. And then you go to the methods section, and by time 4, you're down to like 175. It's not always that extreme, but you would think about that. It's something you want to comment on when you're critiquing a paper. How happy are you with the total attrition from the beginning to the end, and what did they tell you about who was left and how biased that remaining sample was or wasn't? Sequential designs we'll really get into in more detail when we get to the lifespan developmental psych section, but it's a way of kind of doing a combination of ongoing sampling cross-sectionally and adding more and more cohorts to your sample so that you can analyze both cohort effects and longitudinal effects, and you can keep throwing people into your samples. And it's better. It doesn't solve all the problems. It's expensive. It takes time. Nobody's going to start a longitudinal study for their master's thesis or their dissertation, right? 'Cause you don't want to wait 20 years to finish up. So. Which is actually one of the other issues is because longitudinal studies have to embrace a long period of time, you're mostly stuck with data sets that somebody else created, which probably don't match the question that you really want to ask. And you end up with interesting issues about what variables you're using. Like, if you're studying intelligence and you take whatever the best intelligence test is when you start, and then that test gets revised 2 or 3 times while the study's going on, what do? Do you use a revised test and have ways of converting the scores so that they're all in the same system, or do you stick with the old test, which now nobody cares about anymore because it's the old test? And
I can find everybody else that you previously tested.
But you have to test them at that age. Yeah, good try, though. Okay, age extreme comparisons. Probably fine if what you're actually looking at is experimental manipulations. We'll talk about this more in the next few sessions. Also, arguably is a good way to start any study. If you don't have differences between very old people and young people, then you're probably not going to have effects to look at course, you could have things that like change from young adulthood to middle age and then take you back, so then you'd miss that. But the problem with that logic. Again, do you think the age extreme comparison is really what you're interested in? We already talked about the differential attrition, and then think about whether the pros and cons of experimental designs versus survey type studies for whatever you're looking at. We'll fill that in more as we go. Survey type studies is you're handing out questionnaires of different types and seeing what happens with that. It ends up pretty much always being correlational research. In principle, in experimental designs, you can control and manipulate some of the variables of interest, and therefore you can think more about causality and what the processes are that are making old people and young people different. Kind of the golden fleece in this kind of study is that you can actually find a way to make the young people act like old people, or the old people act like young people, in terms of whatever your variables of interest are. You know you've really got a key variable if you can move your old people's scores down, up or down to the young people's scores, or the other way around, if you can mess up the young people or enhance them. It's the case maybe you make them act like old people. We'll talk more about the mean differences and correlation stuff in a couple of weeks. The simple thing here is most statistics, no matter how complicated they are, basically fall into one of these two categories. You're either looking at differences between groups, and what the question is, is the average of this group enough different from the average of that group that we can conclude that they're different? And then, we usually jump from that to conclude that everybody in this group is different from everybody in that group. That's totally the wrong conclusion, but we'll talk more about this as time goes on. This tends to be the way we think about things. Or you're looking at how two variables are associated. And so, particularly so experimental designs tend to look a lot at mean differences. There are other kinds of studies where you're looking at differences between groups based on survey data where you might look at mean differences. Or you're looking at how is age correlated with this, that, and the other thing. And there, as you get into more complicated analyses, you can try to control for some of the other things. If you can do that, if you've got the stats to think in some depth and critique the statistical analyses and the findings, feel free to go ahead and do that. If you can't, don't worry about it. You're not expected to for the purposes of this class. Just look at the simple statements of results in the results section. And what you want to look for as much as you can is your own appraisal as to whether the statement of results in the results section actually do confirm the hypotheses at the end of the lit review introduction section. They may or they may not. If authors acknowledge contradictory evidence, it's most likely to be here in the results section. Now, almost every scientific study that's ever done is you get this really great idea. Well, sometimes it's a pedestrian idea, but if you're rolling, you get a really great idea. You're absolutely sure it's going to work. You design your study to be something between a fair test and a test that's going to get you the results that you're hoping for. And then you get results that, some of which, the most typical thing is that some of the results confirm your ideas and some of them totally contradict your ideas. And some of them you don't know what to make of. Sometimes nothing pans out, in spite of your best attempts to make this work out. And almost all researchers will own up to this in the results section.